So, good evening, dear participants. Welcoming you all for the second day of the National Research Methodology Program on SPSS Excel and academic writing. And yesterday, hope you enjoyed the session well. And yesterday, we have sent you the session to all the registered mail IDs. They will be the same. So, once the class is completed, we will be sending you the stream for your further study purpose. And now it's a time to welcome second day. And without much delay, let me hand over the session so Shobna ma'am, and today we'll be learning the different aspect. She has sent me one file. That file I have forwarded in the group. So kindly get ready with the file. And if there is any doubts or questions, definitely the resource person will give you enough time for interaction, and that time you can ask your doubts and you can clarify everything. Meanwhile, requesting all the participants to mute yourself, ensuring that it has a proper and smooth flow. Meanwhile, I'm in the travel. Now and then I will be connecting. But anyway, I'll be coming with another device so that we'll be having a proper connectivity. Okay? Without much time, let me hand over the session to Shobna.
Yeah, thank you, Bennett, sir. And good evening, participant. For the second day of this international workshop, so we'll wait for 2 minutes more. I would like all the participants to get ready with their data set. Already, Bennett sir has shared with you all. You can just get ready, opened with the data set, just to simultaneously try to understand when I'll be explaining about few terminologies. Uh, okay, so let us wait for just 2 more minutes for that the participant who are going to do along with me get ready with the data set. So once again, a very good evening to everyone. And today I will talk about regression analysis in research and performing linear regression in Excel, which is the fundamental statistical tool used in research. Also, I will demonstrate how to perform the linear regression step by step using Microsoft Excel, making it practical and easy to apply. Here's the outline for today's presentation. We shall start with an introduction to regression analysis. As I previously sounded that whichever topic we will be this starting with, of course, we should know some theory concept of that. So, like yesterday, today also, I'll be discussing few required terminologies known for this topic and then shall process in performing the linear regression in Excel. Also, finally, we discuss how to interpret the result and important considerations. So, what is exactly a regression analysis? Regression analysis is a statistical method used to examine the relationship between a dependent variable and one or more independent variables. So, here you should first understand that there are two types of variables, and you are capable enough to identify which is the dependent variable and which are independent variable. So it says it's a relationship between a dependent variable and one or more independent variables. Your dependent variable will be only one, that is output, but your independent variable, to get that output, you can have one or more than one independent variable. Depending on the number of independent variable, the regression will be further called as simple linear regression or multiple linear regression. That is what, if you can see in the data set, there are two sheets in today's session. Okay, so when they will be discussing further, I will just guide you on that. So it helps us model and predict outcomes and is widely used in many disciplines like economics, biology, social science. So when I say social science, so all the stream, right? To draw meaningful conclusion from the data. So why use regression analysis? The main purpose of regression analysis to predict the outcomes when it is not known specifically. Understand the influence of the predictors. So here with one of the value, we can understand how much percentage a particular predictor has influence towards the dependent variable, and optimize the process by identifying the trend. Especially it's about learning from data to make informed decision. So when I say that it is used for predicting, and it helps us to model, that means we should have a standard model so that when we analyze our data, we substitute the obtained parameter in that generalized model and further use it for the prediction. So the standard linear regression model is y equal to beta naught plus beta 1 x plus e. So if you very closely observe this equation, just ignoring the last term and slightly changing the notation, you can recall that it is a equation of a straight line, y equal to a plus bx, the standard notation which used in junior level and maybe in school. While in school we have used as y equal to mx plus c in order to draw a straight line for given equation. So hence that itself we have started roughly about statistics, that is but there was no error term in that because just we were plotting a straight line. But now why there is an error term which is called as unexplained variation? Because we are predicting, we are going for a prediction. So y dependent variable, which can be also called as outcome, x independent variable, which we say as predictor. Here I have written the model of a simple linear regression because it's only one independent variable. If you are going to have more than one independent variable, so just extend the equation by beta 2, beta 1 x1 plus beta 2 x2 plus beta 3 x3, so on. And then the model will be called as multiple linear regression. And we say beta naught and beta 1. This I have just written the term to recall what you we were being known, intercept and slope. Generally when we learn this theoretically, to understand this concept we say it is parameter. So beta naught and beta 1 are the parameters which has to be estimated. Okay, which has to be estimated. That is what we are going to see in today's session using Excel. So what is the step? What are the steps in performing regression in Excel? So as we had seen the descriptive statistics using the statistical tool pack, of course similar procedure only. Okay, so when we will be uh, doing in Excel, I will performance show you again, of course. So just for your information, you can just note it down that we have to have independent variable and dependent variable to in a column adjacent, and to follow the or to have the consistency of the data, we ensure that there is no blank cell. So to perform that, we have to enable the data analysis tool pack. So yesterday you all have been done. So no need to do that once again, not required. But still, many couldn't do so. I have uh, shown the step today here. You can just perform and see if those have not done yesterday. File, options, add-ins, go, then analysis toolpack and okay. So by following this process, you can enable the data analysis toolback. Of course, once it is enabled, you can go to the data tab, and on the right side you can find the data analysis, and from that we can use the regression option further to perform the analysis. So as we have seen in the last class, same way the procedure would be inputting all the required inputs, labels, and selecting the output range, etc. And then you get the output. And once you get the output, you are set ready to interpret the output. So Excel will generate a detailed output table. The key parts include the coefficients, that is the intercept and slope, or what you can say the parameters, the R square, which tells us how well the model explains the data variation, and always close to 1, that is closer to 1 is better. Standard error, which indicate the estimation accuracy, and finally the p value test the statistical significance of the coefficients. And once we will be getting all this value, that is using these coefficients from Excel, you can predict the values of y for new values of x by plugging them into the regression equation. And this makes the regression very useful for forecasting. So in short, I explained how to go with the regression analysis. But very important in that, we should be very careful in verifying the underlying assumption to ensure that your conclusion are reliable. Okay. So without checking the assumptions also, we can just perform the step, you will get the answer. To ensure that your conclusions are reliable, the following assumptions, if it is satisfies, it would be very good model. So assumptions like checking the linearity, normality of schedule, homoscedasticity, and finding the outliers. This can be done by different diagnostic plots, but the limitation of Excel is it can't provide all these diagnostic plots. So this assumption verification I will show you in detail when we will be doing in SPSS. In this session, I would show you few assumptions which we can visible in Excel, and of course I will show you the detailed step of performing the regression in Excel and the interpretation part. Like first, linearity. So the first assumption of linearity should be satisfied because our model is called as linear regression model, because there are different other tools or method procedure available when it is non-linear. So first thing is linearity, since a model itself says it's a linear regression model. So we can see in that equation the power is 1. So how will you verify that the assumption of linearity, that is there is a relationship between independent and dependent variables are linear? So simply by plotting a scatter plot. The last lecture we have seen bar chart, pie chart. So that time I just said that the further whatever graph is to be coming accordingly we will discuss. So that graph was based on one variable, but to understand the relationship between two variable we have to use scatter plot, which will be directly in the insert option. And if it looks like a straight line, then we say that we will not say always 100%, but we can say that approximately it is linear. It's not required that it will be always exactly straight, but somehow non-linear means it should not form like a curve. That is what. Second one, independence of residual. Basically, this assumption is checked for time series type of data. Basically, it is used for time series data. The third one, homoscedasticity. Here we check that the residuals have constant variance across all level of X. So this can be also done in Excel. We have to compute the residual first. So just to for your remembrance, I have written in this the detailed formulas on each and every slide what has to be done. So we compute here the residual, that is the actual value minus the predicted value of y. Then we create a scatter plot between the predicted value of y or x with residual to check the consistency. So there should be, it looks should look like a random points for this assumption. There should be no pattern like. Next is the normality of the residual. So again here to some extent we can do in Excel to check the residuals are normally distributed or not with the help of histogram, again by calculating the residuals only. That is, you have to create the plot the histogram for residue. The alternative one is the better one, QQ plot, commonly called that is called as QQ plot, which is normal probability plot, which is not feasible again in Excel directly. You can do it by putting so long formulas, but not that required. But it is feasible in SPSS. So, how do we verify that it is normal? So, the normality is suggested by a bell shaped histogram or a linear QQ plot. So, these are the assumptions which has to be verified for simple linear regression. If you come across with multiple linear regression, in that case one more assumptions to be satisfied. We have to check that there is no multicollinearity. That is, the independent variables should not be highly correlated. So that can be easily computed again in Excel also by using the functions correl, CORREL. Also in descript the tool pack, you are having correlation coefficient option. From there you can create the matrix of correlation, and if the correlation values are close to zero point 0.8 and above, we indicate that multicollinearity is present. That means the two variables are related. In that case, multiple linear regression is not possible for that. So first we have to detect that and do the required measures on that. So overall, this is the summary of the assumptions, how to detect and verify. So to summarize about this topic, theoretically, what just to know the basic to start with the practical. So the things which has to be known is to identify the variables. That is, you should know there are two types of variables, independent and dependent, and you should able to identify that. Then once you perform, you are able to identify the coefficients and able enough to interpret the output. So in this way, regression is a powerful tool in research because when it comes under prediction, fine. So that's all from my side on this theoretical part. Let us move to the hands-on session. That is, let's see how we perform in Excel. So you can all just wait for 2-3 minutes. You can all get set with the data. Then we shall proceed further. Okay, I think now we can start. Let me first explain you the data set. Here the first sheet says our goal here is to predict the sales. So what I want to predict, that would be my dependent variable. So I want to predict the sales based on advertising budget. So that means my advertising budget would be the independent variable. So I'm repeating once. The variable which we want to predict, that will be the dependent variable. So here we want to predict the sales based on advertising budget. So sales would be our dependent variable and advertising will be our independent variable. So while after performing the required steps for regression, once we get the coefficient, how the model will look, it's like sales equal to beta naught plus beta 1 into advertising budget. This is what our equation would be after performing the required steps. This is how our regression equation would be. That is y equal to beta naught plus beta 1 x. Similarly, for the second sheet, predict the exam score based on our study and attendance. So, in the first case, we add only one independent variable, that is advertising budget. Hence, we say it as simple linear regression. Here we have two independent variable because I want to predict the exam score. So exam score will be the dependent variable and predict the exam score based on what hours studied and attendance. So two independent variable. So of course these two independent variables are not dependent, and this is the case of multiple linear regression. Okay, so here how the model would be: exam score, that is your exam score will be equal to beta naught plus beta 1 into study hours plus beta 2 into attendance. And if you will be having still more independent variable, then you will be just going on adding to that plus beta 3 into plus beta 4 into and so on. So now over to the Excel sheet. So let us see the procedure using the data tab, that you will find the data analysis tool pack under data tab. So in that you can find the option regression. So you can see the format. It is similar to the what we had in the last class. You will be having a space for inputting the value, then labels, then output option, then what is required, what are extra you required something. In the previous case we had summary statistics, and here you can see about the residuals in detail, because that is required for the assumption property, right? So the important thing is you input the x and y properly. That is very important. But just to see how the scatter plot look, how the scatter plot look. So you can select the data. Only the independent variable and dependent variable. And of course it's 2D. So only two variable at a time. Even if you go simple, though we'll be having only two variables, one from independent and one from dependent. But when we go for multiple, in that case, we will be doing two at a time. So insert, you are having the last chart option. Even in recommended chart, you can find the scatter option and just click on that. So it is somehow linear only, right? It's a linear because it's not a curve. You can also simply plot it and see about the point without the line, just to understand whether it is forming a curve or not. Okay, so x and y can take, just you have to insert the graph of scatter plot. So linearity assumption is very clearly satisfied here. If not, then you can see the various different reference book on regression analysis for transformation, using different transformation techniques to make it linear, or else go for a non-linear technique, depending upon which type of non-linear it is. So this is the first step. So usually you can have x and y either side, no worries, just there will be change in the scale. But generally our first would be the x, because that value takes in the x axis, and second column should be y. Even if you swap, you will get an output with slight variation in the scale of the. I would like to show you that also. In case, I mean, if you have this x information, because this is our budget, advertising budget is our independent variable, right? So in this, if you are doing in this way, that is first column is y, then just to show you how there is the change. Okay, so only scale will be different. that is in the axis, but the graph you can, okay, it is just a mirror image what you will be seeing, that's all, from the above side. So the, of course, the preferred one is this only first one. Hence we always can to keep the x data first. Okay. For linear regression, we can get the model and about the goodness of fit value also by a shortcut, that is by a inbuilt layout through the chart design. There is one inbuilt layout in the chart design only for simple linear, okay, because it can work only for two variables. There is a inbuilt layout in chart design in the left side corner under quick layout. There are around 11 layouts, among them the ninth one. You can just try if you are performing this. You can just see the under chart design quick layout, the ninth layout, which shows the following chart elements like chart title, legend, series trend line with equation. This is the layout which gives you with the equation. When you click on that, you can find the equation framed for this particular model, that is for this particular data. So this is the equation, and r square which can be used for the interpretation, that is in the form of y equal to mx plus c. So you can just write it in the according to our way, y equal to beta naught plus beta 1 x. I'll give you 5 minutes. I would like everyone to try and see the system, those who are performing. Those who are performing, I'll wait for 5 minutes. You can perform and see. Yes, sir. So you must have all tried this. Now coming to the regression step using the tool pack, and let us verify our answer. So you will find in the option data, data analysis, regression. Okay. So first you can try putting all this input. First I'll just give you a few minutes. Try from your side by inputting the correct range, and then I will perform and show you. You can verify it. First, you can take a chance to just check how much you are able to do in inputting the value correctly. So what is the range you have selected under the input Y range? So full you have inputted the Y variable, that is our dependent variable data range. So that would be sale. Yes, along with the column name. Then X range, that is our independent variable. Come to the tab, select then few to be selected. Labels, of course. Constant is 0. That is an other case. Here you have to simply go for labels one. Confidence level, if you want to change, you would like, but by default we always take 5% level of significance. That is 95% confidence interval, right? Output range, you can select any one cell, and we to see to that we have enough space below and right side. And you would, if you want, you can select the residual plot and normal probability plot, and okay. It will just take few seconds to analyze, and you will get the result. Yes. We have got the summary output. So here is the summary output. So first, if I want to match, you can see the R square value, which is 0.99706. And that is what you can see in this chart also. 0.9971, round off to 4 digits after decimal. Okay. And what was the purpose, and what will the R square interpret? If you just see the slide what we have discussed, R square is used for the to know the goodness of it, how well the model is fitted, and it will also interpret how much variation has been explained. That is, what is the percentage of this independent variable influenced for this prediction. So, of course, here we have taken a data set for example. So, we have got 99.71, that is almost very close to 1, a very good model. That is 99% of variance that is variation has been explained by this independent variable, that is the advertising budget. And it says that in order to predict the sale, the data, that is the advertising budget as 99% role or influence, just 0.1% is due to other factor. Fine. Next, coming to the model which is being obtained directly in the graph. So let's see the coefficient value in our output. So if you see the coefficient values, so it is 10.165, that is beta naught, and 1.39 beta 1. So you can check here, yes, 10.16 and 1.39. Okay, so this is how we get the coefficients for this regression model using the tool pack. I'll wait for two few minutes. You can perform and see and just verify your answer before I go for the next. Hope you have performed this regression step using the tool pack and you got the same output. Your coefficient value is showing 0 because you must have selected that coefficient value as considered to be 0 in the beginning. When I showed you the step of inputting the data, next to label, there was one option, na? Coefficient is 0. So I told we have to not select that. If you would have selected that, then you will get by default the coefficient value as 0. Okay. So accordingly, you can make the change and once again perform and verify your answer. So we can move towards the next step now. Now let us see what all assumptions more can be verified from this inbuilt one. To the analysis tool pack, we could get the plot of residual versus predicted value. Also, or if you just seen in this assumption of heteroscarcity, it was mentioned we can create a scatter plot predicted y or x versus residual, which is this plot which we have got. X versus residual. X is the advertising budget versus residual. Also, one more, that is normality of residual. So here to check either we have to go for manually histogram or QQ plot. So here the normal probability plot is the name which is in Excel. QQ plot we see in SPSS. So if our normal probability plot is looking like a linear, that is look somewhat like straight line, that means even this assumption is satisfied. So let us have a look on that also. Yes, it is linear, isn't it? The lines are linear. That is, I mean, the points are linear, so that normality assumption is also satisfied. So hence, this regression model would be a reliable model? See, you can perform as a standard statement. You can perform any analysis for any data. That particular model or interpretation would be reliable if the following assumptions are satisfied. So you can see here the minimum required assumptions are satisfying. So this particular model will be a reliable model and the interpretation would be also reliable. So this is what I was saying, that since here we had the option of residual, so automatically it has calculated. Automatically it is calculated uh, with that formula, and it has computed the residual value, and then it has performed the procedure to compute the plot. Okay. So now moving on to the one more summary part. If you remember in this, let me come back to this slide once again. Mm. So we have seen the coefficient, we have seen R square, we have seen standard error value also computed, and significance value to see whether my model is significant or not. So that will be given by the p value. This is the significance f. This is the significance f, also called as the p value. So it is 2.03221 e minus 11. Many get confused that this value is just 2.03. No, it is 2.03221 e minus 10. Sorry, minus 11. That is the value into 10 raised to minus 11. So 10 raised to minus 11, when you approximately write the value, is 0.10 times 0 and then 20322, and which is approximately, we can say it as 0.0. Okay, so because we generally go for only 4 digits, so approximately this is 0, and we have to check with 0.05 value, the standard alpha value for comparison. If you recall, in the starting, that is when we had inputted here by default, I'll just show you if you want once again. Here confidence level 95% means alpha is 5%. So you have to check with that alpha percent, that is 0.05. So it is less than. So please just everyone get back to your significance value. Just find you're able to, and kindly make a note for that interpretation. If p value is less than 0.05, then it indicates significance. So statistically, it is significant. So statistical significance. Okay. So statistically, this model is significant. So we can write statistically, the model is significant. Okay. So I would like to give you again 5 more minutes. Please go through this step one by one. I'm going very slow so that I want everyone to understand each and every step. While seeing it might look very easy, yes, agreed, it is easy. But when you actually then perform by yourself, then you may stuck up somewhere. So now it's your time. If you perform and if you stuck up, you can ask me now directly so that you can avoid mistake later and you can get a confident in yourself. Okay, I'll wait for 5 minutes. Then we will continue with the next model. Hope you all have done with practicing the simple linear regression. I think so. Now we can start with the next model, that is multiple linear regression. So now here we have taken the example of multiple linear regression. So I'll give you first 5 minutes to you all. Try what all you understood in the first model. Everything remains the same by the analysis tool pack. First try from your side what all you are able to do. Then after 5 minutes, I will show you the steps. Then you can verify how much you could do without my help by understanding what we have done before. Okay, so I'll give you 5 minutes to all. First try from your side how much you are able to do. So anyone tried going till what step? Let us see now. I will perform and show you. So in the similar lines, you have to go data tab, data analysis, regression. Okay. Now in input range, you will be having the exam score, right? For under Y range, because that is our dependent variable, and our independent variable. Here we have two variables. So you have to select both the variables together. That is the only difference. The only difference is the previous one you had only one variable to be selected. Here you have two variables and both the variables to be selected together. Since it is multiple, there is no direct layout, because in layout we can do only two variables, right? For x and y, only 2D. Here we are having three variables total. So we have to go only by the analysis tool pack. So your output, summary output will have a similar pattern only. First you check how well your model is. For simple linear regression, we used to take R square. For multiple linear regression, we go for adjacent R square. So of course here also it's 0.99, a very good model. That is 99% of the variation has been explained by these two variables. These are the two factors, and just 1%, it is zero point 0.5 almost point, and that is by this 0.1%. What it is 0.1% is by the other factor. Standard error is also not too high. And to check first whether the model is statistically significant. If the model is statistically significant, then only you have to go for writing the model. That is building up the model, what we say. So here also it is 6.4. So many may, if they have a misunderstanding, they may feel 6.4 is a big value. It is actually 6.4. E minus 0.9, that is 6.4 into 10 raised to minus 9. That is 0.8 zeros and 64, which is approximately 0 only. So that is less than 0.05. So this model is also statistically significant. So then we can come to the coefficients. Before going to the coefficients in multiple, not this is not required for the simple, because simple only one variable is there. Therefore this verifying this overall significant is enough, because only at one variable it is for this is computed based on that one variable only. But when it comes to more than one variable, first we have to have a look on this p value. That is the p value for individual independent variable. So this two, okay. because the first one is the intercept, no need of that. So under p value we have to see the p value for the independent variable. So both the p values here is, so let's see the first one. It is 1.4 into 10 raised to minus 6. So it's approximately 0. And this p value is used to check the significance of individual variable. I'm repeating again. The first one under ANOVA table, the significance f value is to check the overall model. See, sometimes you may come across with 10 variables. Overall, the model would be good, but few variables is not that much contributing and it is not significant. So you can ignore that for prediction. Likewise, here also we have to check. And what does this information gives on based on this data? For the first one, study hours, p value is less than 0.05. So study hours is significant. But if you check the attendance, it is slightly big than the 0.05. So attendance is not significant at 5% LOS. I'm repeating this. Attendance is not significant at 5% LOS, but it is significant at 10% LOS, because we can use three values: 1%, 5%, and 10%. Standard is 5, but if it's somewhat close, in that case, you can go for 10% also. But if you want to stick to 5%, well and fine, not a problem. You have to say that for at 5%, the significant model is only with study hours, but at for 10% significance, the model is study hours as well as along with the attendance variable. That would be the difference. Okay, so this is all the small things which has to be remembered and observed very carefully uh, for further. So here you can see the normal probability plot. It's normal, right? Because it's new, and here also it is random. The residual plot is random. And now you can come to the coefficients. So how will you build the model over here? So here it is exam score, right? So exam score equal beta naught, that is 30.33 plus 4.36 into study hour plus 0.17. So attendance is not affecting more in the exam score. That even if your attendance is low and if you give more effort in studying, your score would be good. That is what this model says. Okay, according to this observation, see, every observation would be differing. So, according to this observation, study hour is more focused. Even if your attendance is low, if you give more effort on study hours, you can score a good marks. That is what this means. Into attendance. This is how you will build. So, for example, if you want to find that if a student is studying for say 12 hours, okay, and so what you have to do, 30.33 plus 4.36 into 12 hours. So the marks scored will be 82 with 0% attendance. Okay, 0% attendance, but he has studied for 12 hours with the notes. Along with that, if he has studied for few hours, say only 3 hours, and with a few percent of attendance, say 50%, so only attendance, that is what your attendance is showing as insignificant. Okay, because the marks is focused mainly on based on the study hours, on the study hours. Okay, right. So I would like to give you 5 minutes again here to perform and see those who have not done. You can, I think you must have noted the step. You can perform and see, and any doubt you may ask. So hope those who have been performing along with me, you would have practiced, and I hope you would have got the output also. So this is how you perform the regression analysis using the tool pack. Since it is multiple linear regression, you have to go for one more assumption, that is multi-collinearity. You can check it with the help of coefficient, that is correlation coefficient, which is available in the data analysis tool pack. Correlation. Okay. Input range. You have to take all the three variables, independent as well as dependent. Label in first row. Of course, group by column by default. Output range. You can give a blank space enough. Let us give below this output only. And okay. Okay, see, here I missed to select the labels. Hence, by default, it has taken that value. So let me perform this again. Data analysis. So while selecting, let me take in a fresh sheet. So data correlation. The range was not selected properly in that. And let us take the new cell and okay. So this is how you will get the matrix. Of course, diagonal will be 1 because it is correlation between its own variable. We have to just check these three values. So you can see your attendance and study hour is highly correlated. That is what the reason why that attendance was showing no impact, was not significant. See, this is all the reasons you will come across with when you go in detail. Okay, so here no need of the exam score. So multicollinearity assumption. So check for the independent variable. Hence, we have to check the correlation between study hour and attendance. That is the required one, so which is 0.899. So it's too high. Hence, even in the ANOVA, we were getting an attendance to be not significant. Okay, so this is all you can verify in this way. Hence, only study hour was more than enough for giving the prediction for estimating the exam score. It will differ upon the data types. Okay, I'm repeating again that. And overall, your data should be quantitative type. That is, of course, the first thing, then only we can perform in Excel. If your data is qualitative, no linear regression is feasible in that. Then we have different types of regressions according to the type of data and the scale. You can go with that logistic regression in other statistical tools. In Excel, it is suitable only for quantitative type of data. So let me overall summarize what we have done. So would like to again give a final summarization in this. Study hour is more strongly having the impact compared with the attendance. That is the difference you should identify. Okay, and not necessary in all the problem you will have depend upon the data set. So I hope in this session you have explored how linear regression can be used to analyze the relationship between the variables. Uh, the simple regression showed a clear link between advertising and sales, while in the multiple regression emphasized the combined effect of the study habits and the attendance on exam performance. Both the models demonstrated a high predictive power because the R square was pretty good. So, this is how you apply the regression in real world decision making. Hope you have learned the basic requirement to understand about regression from this session. And thank you once again from my side to the organizing team and the participant for being attentive and giving the response throughout the session. Thank you so much. So I can give you 10 minutes. Any doubt regarding today's session? Also, any doubt regarding the yesterday session after practicing? If you have practiced the work given and you are having any doubt in that, you can ask that too. Thank you from my side.
Uh, Hi, ma'am. My name is Saru. Actually, I wanted to ask. Everything is clear. It was excellent session. Just only one thing I want to understand, that how to know the p value is significant or not. This point I was not able to understand the calculation. If you can help.
Yes, ma'am. P value, you have to just compare it with the 0.05 standard level of significance value. We compare the p value with the standard level of significance, that is 5%, which is 0.05. So
Yes,
my
ma'am,
p,
that is fine. But the calculation, the way
okay,
you have
okay.
to
Haha,
calculate
got
that.
it, got it. In some place you have been having E, right? E.
Yes,
So
ma'am.
yeah, if it is E minus something, that means it is 10 raised to minus that value. If it is E minus 0.6, that means the value into 10 raised to minus 6. So 10 raised to minus 6 means what? 0.5 zeros and the value. So it is approximately 5. So generally if it is coming E minus 0.405, that means it is approximately 0 only.
Okay.
It's like when we write 10 raised to 5, we add 0 to the right hand side, the value increases. And when it is 10 raised to minus 5, we add 0 to the left hand side with decimal, the value decreases. That is what E minus n plus meaning.
Okay, ma'am. Okay, thank you. It's clear now. Thank you.
Yeah, welcome, ma'am. Okay, ma'am, please show the result of to check the multi-coordinate. Ma'am, you have to just perform correlation analysis and you will get that value.
Yes, ma'am. Everything else was clear. I was able to do it. Thank you, ma'am.
Yes, yes. Yeah, welcome, ma'am.
Dear participants, very good evening. Thank you so much for your active participation. Successfully, we have completed 2 days and 8 more days to go. Sincerely thanking you so much for your active cooperation. And I'm very happy that you people are really doing the answer session with the same effort, the same power.
Okay, there is some connectivity issue. Uh, and so if there is no more doubt, uh, we can stop over here and see you all tomorrow with a new topic. Thank you so much, everyone. Bye bye.